We're going to find the volume of the solid of revolution obtained by rotating a region bounded by the graphs of y equal to 2x squared minus x cubed and the x-axis about the line x equal to 4. First, let's find where this function crosses the x-axis. Find its x-intercepts. We take 2x squared minus x cubed, set that equal to 0. Factor out x squared, so x squared times 2 minus x equals 0. X equals to 0 or 2. If I then take any value of x between 0 and 2, say x equals 1, plug it into this function, we find that y is 1. It is positive. It means that the graph is always above the x-axis when x is between 0 and 2. And so we can now sketch this region and set up the integral to find the volume of the solid of revolution. Here's what the region looks like. It looks something like that. This is 2, and this is the graph right here of y equals to 2x squared minus x cubed. If we bring in the axis of rotation, the line x equal to 4, and keep track of this vertical slice of the area corresponding to an arbitrary x between 0 and 2, we find that we generate a shell. We're going to use the shell method to find this value because the washer method is extremely difficult for most calculus students. So the problem comes down to finding the surface area of the cylindrical shell as a function of x. Recall that when you have a cylindrical shell that looks like this, we have a radius r and height h. If we cut the shell along this side, along the height, and then unfold it, we end up with a rectangle that looks something like that. The width of the rectangle is h, and the length of the rectangle is what used to be a circle, the base. It's the circumference of that circle that's now the length of this, which is 2 pi r. And therefore the surface area is 2 pi r h. And so we now have to express this as a function of x. The volume will be 2 pi times the integral between 0 and 2, because that's where we're taking our values of x. And now we have to find the radius and the height as functions of x. You can see in this picture that the distance from the axis of rotation to the y-axis, this whole thing, that's 4 units. This distance right here, this is x units, and therefore the radius is 4 minus x. 4 minus x is our radius, and then the height is just the y-coordinate on the graph, which is 2x squared minus x cubed. And that's the integral that we have to evaluate in order to find the volume of the solid of revolution. So this is 2 pi times the integral from 0 to 2, and then we have 8x squared minus 4x cubed minus 2x cubed plus x to the 4th power. Let's simplify this and then evaluate it. So this is not a difficult integral at all. We have 2 pi times the integral from 0 to 2, 8x squared minus 6x cubed plus x to the 4th. And this is equal to 2 pi times 8/3 x cubed minus 6 over 4, that's 3/2 x to the 4th, plus 1/5 x to the 5th, evaluated from 0 to 2. Plugging in 0 gives us 0, and so all we have to do is plug 2 in. So this is 2 pi times 8 times 8, that's 64 over 3. 16 divided by 2 is 8 times 3, it's 24. So 64/3 minus 24 plus 32 divided by 5. And this is 2 pi times the common denominator is 15. So multiply 64 by 5, that's 320. 24 times 15 is 360, so 320 minus 360 plus 96. And then let's add and subtract all of that. 320 minus 360 is negative 40, plus 96, that's 56. 56 times 2 is 112. So the final answer is volume is equal to 112 pi divided by 15. For more videos,